Good afternoon, everybody. Today I'll be doing lesson 6.3 Binomial Radical Expressions. Got it, problem number 2, using radical expressions. From problem 2, find the perimeter of the window if the side of each small square is 6 inches. So, right off the bat, we know that we're looking for the perimeter and that the side of each small square is 6 inches. Well, if we know that the side of each is 6 inches, however, it doesn't exactly line up to the sides of the window, which are using the diagonals of the squares. How exactly would you look for the diagonals? Well, you simply have to multiply the side length with the square root of 2. And since we know that the side length is 6, we can just fill in that spot right there. And then, like that. And so we know that the length is made up of 1, 2, 3 diagonals. And we know that the width is 1, 2 diagonals. So we just have to multiply these two, and you'd get 18 square root of 2 and 12 square root of 2. Alright, however, we're still missing 2 other lengths, which are identical to the other ones. So all we'd have to do is multiply them by 2. So 2 times 18 square root of 2. And since we're finding the perimeter, we can just add right here. 2 times 12 and square root of 2. So then we just multiply these two. 36 square root of 2 plus 24 square root of 2. Alright, we add these two, which will give you 60 square root of 2. And for this next part, you'll need a calculator. However, I've already done it. I have it right here with me. And well, you'll have to solve for the square root of 2. And if you use the calculator correctly, and if you round to the nearest 100, you'd get 1.41 there. And then we'd also have to multiply it by 60. So if you do the math correctly, you should get 84.6. However, you can just round that up to 85. So the perimeter of the window, if the side of each small square is 6 inches, would be 85 inches. Here we have part B, which is describe a different sequence of steps that you could use to compute the perimeter of the window. Well, right off the bat, I noticed that these look a lot like triangles. And one of the theorems that I know and learned of last year was the Pythagorean theorem, which is a squared plus b squared is equal to c squared. Now we know that these lengths are 6 each, as they are the same sides to the squares. So 6 squared plus 6 squared is equal to c squared. 6 times 6 is 36, and if you add those two up, you get 72. And now to find the square root of it, you might need to use a calculator. So I have one with me right now. If I were to put it in, I'd get 8.5. I rounded up since I had initially gotten 8.48. So since I rounded up, I use 8.5. So we have 3 diagonals for the length. So I'd use 3, 8.5, and 2, 8.5, because the width is 2 diagonals. So multiply right here, 3 times 8.5, I get 25.5. And over here, 2 times 8.5, I get 17. We're not done yet because, again, we only did 2 sides instead of all 4. But since these are identical to each other, I could easily just multiply these by 2 and then add them, since we're still looking for the perimeter. So 2 times 25.5 plus 2 times 17. 2 times 25.5 is 51. And then 2 times 17 is 34. So then if you add them together, you get 85, which was our answer to the previous problem. So as you can see, this sequence of steps did work. So you could either use this one or the last one, whichever one you find easier. However, the last one is the one that they showed us in the book. So, yeah, that's all you need to know.